Welcome to our lesson for section 1.2. Today we're going to be talking about sampling methods. Remember, a sample is going to be a subset coming from the population. So, for example, if your population is all GRC students, a sample could be 100 of the GRC students or 1,000 of the GRC students. You get to decide how big your sample is going to be. Okay? So we're going to focus on methods to select a sample from the population. So here are our learning objectives. Identify the sampling technique used to select a random sample. The second learning objective is to determine the appropriate sampling technique given a research topic. So why do we need to be able to select a sample? Well, because gathering information about the entire population is often very expensive or is sometimes impossible. So instead of studying the whole population, we use a sample of the population. Okay? So a really big remark that I want to make here is that a sample should have the same characteristics as the population it represents. In other words, the sample needs to represent the population. So how can we do that? Well, first, we can go ahead and ensure that individuals are being randomly selected from the population. So let's talk about the first technique. The first technique we're going to see is called simple random sampling. In this method, every member of the population has a chance of being selected. In fact, every member has an equal chance of being selected. How do we accomplish this? Well, we go ahead and take the population, so every individual in the population, and we assign a unique number to each member. Then we use a random number generator, and you can find any random number generator online. We use this generator to select people. Another way to perform this sampling method is to put the names of each member of the population into a hat, and then you can randomly pull names out of the hat to determine who's going to be part of the sample. Okay. The visual below should help you visualize a simple random sample. Notice within this rectangle, we have dots. The dots represent everyone in the population, individuals in the population. Okay. The ones that have been circled are the individuals that were randomly selected from the population. And so let me give you an example. So consider a college population of 8,435 students. If you're using a simple random sample, you would create a list of all the students in the population and you would assign a number to each student. Then you would use a random generator to select 120 participants to be part of the sample. You can use this visual to help you visualize the example. Imagine this big rectangle is the population. Inside this rectangle, we would have 8,435. We would need to create a list with all the names of individuals in the population. So with the names of all the students at this college. So 1 would be one student, 2 would be another student, and so on. All the way until we get to the last student, which would be number 8,435. So once you have the list, and you can think of each of those dots inside of the rectangle being a number. So 1, 2, 3, 4, 5, 6, and so on. I'm just going to go ahead and take the last dot, and I'm going to number this 8,435. And so with the generator, you would generate a number between 1 and 8,435. The generator is going to give you a number. And so here on this image, we see the number 3 was selected. Okay. We also see number 8,435 was selected. Okay. And so you would continue to generate numbers until you have 120 participants. So that is how a simple random sample is performed. Okay. Now let's go ahead and look at. Now, this is the best sampling method. Every single person in the population gets a chance of being selected. Let's go ahead and look at another sampling method. So the next sampling method that we're going to see is is called stratified sampling. In stratified sampling, the population is divided into groups, and we call those groups strata. In singular, we say stratum. The strata, so each group, are chosen so that similar cases are grouped together. So within each group, the individuals have something in common. Okay, so again, similar cases are grouped together. That is one of the characteristics of this sampling method. Okay, so I'm going to go ahead and highlight it. Now, next, we use a simple random sampling, and this is employed within each stratum, within each group. Okay, so in other words, once we create a group, we're going to randomly select, we're going to use a simple random sample to select individuals from that group. And we're going to continue to do this for each group. So from group number 2, we're going to select individuals. Group number 3, we're also going to select. Again, this is done with each group. On the image below, we see that we have a total of 5 strata, so 5 groups. And so each group has something in common. And notice, we can see that within each group, 3 individuals were selected. So again, a simple random sample is employed for each group. So our sample is going to contain 3 individuals from group 1, 3 individuals from group 2, 3 individuals from group 3, and so on. Okay. So let me give you an example. We're going to use the same population as before. We're going to consider a college population of 8,435. We're going to use this visual to visualize this example. So our population is inside this rectangle. We have a total of 8,435 students. And we're seeing that next we would group the college population by department. Stratum number 1, we can go ahead and say, well, that would be, let's say, the math department. Stratum number 2, well, let's say that is the English department. Stratum number 3, let's say that is the nursing department. Okay? And so on. So each group has something in common. And for this example, there's a total of 6 departments at the college. And we actually do have 6 groups here on our visual. Once you have the population separated into 6 departments, you would conduct a simple random sample to select 20 students from each stratum. That means we would be randomly selecting 20 students from the math department, 20 students from the English department, 20 students from the nursing department, and so on. Notice 20 times 6 is going to give us 120 participants in our sample. So again, for this strategy, we're separating the population into groups. Each group has individuals that have something in common. Once we have those groups, we randomly select individuals from each of the groups. Okay? That is how you can summarize this method. Try to write it in your own words. Now let's look at another method. The next method we're going to look at is what we call the cluster sample. When using this method, we're going to break up the population into many groups called clusters. And so that is what you see on the visual. With this method, we usually have more groups, and you're going to see why once we look at an example. Okay? So once you have the clusters, once you have the groups, then you're going to select a fixed number of clusters, and you're going to include all observations from each of those clusters in the sample. So here, you're not selecting individuals from each of the groups, you're selecting groups. Okay? And that is what we're seeing here on the visual, right? We have a total of 9 clusters. Which clusters were randomly selected? Well, it seems like cluster number 3, cluster number 4, cluster number 8 were randomly selected. So the individuals inside this cluster, so the individuals inside these groups are going to be part of our sample. All other clusters are not going to participate, okay? So that is the main difference between the previous sampling method. The difference between stratified sampling and cluster sampling is that in stratified sampling, you're selecting individuals within each group. In cluster sampling, you're selecting groups, and you're randomly selecting groups. Here we have an example. A socialist wants to gather data regarding household income within the city of Boston. Okay. The city of Boston has 10,493 city blocks. Each block is going to be considered a cluster. So notice here we have many different groups, right? We have 10,493 city blocks. So here we have the population, and the population is individuals in the city of Boston. Now, take a note. How many clusters would we have? We wouldn't have 8 as shown here on the image. We would have 10,493 clusters. And so if we have 10,493 clusters, we're going to need to number the clusters from 1 to 10,493, right? So we're getting prepared to conduct a simple random sample. Then a simple random sample is going to be used to select 20 clusters. Okay, 20 of those groups are going to be selected. Okay? So again, we're selecting 20 out of the 10,493 clusters that we have. So you might be thinking, why are we using this method? Why don't we use stratified sampling? Why don't we use simple random sample? Well, it could be because this method is going to be cheaper, right? Think about the researcher. The researcher is not going to have to visit the whole city of Boston trying to find individuals that were randomly selected. The researcher is only going to visit 20 different blocks in the city of Boston. 20 different blocks that were randomly selected. In this case, we would have fewer travel expenses if we use cluster sampling. Let me introduce you to the last random sampling method that we're going to see. This method is called systematic sampling. In this method, we select every nth individual from a list of the population. The first individual that you select corresponds to a random number between 1 and 9. And so here's a visual that can help you visualize the method. So on the visual here below, we're going to select every third individual is selected. Okay? And so notice, for example, the first individual here on the left is selected. They're going to be part of the sample. And then we select the third individual after that. So we have 1, 2, 3. This individual is going to be selected. Okay? And then from there again, we select the third individual after that. And so we have this next individual being selected. So that is how the method works. That is what we mean by you're going to select every nth individual from the population, right? Now, how do you know where to start, right? So once you decide that you're going to be selected every third individual, you need to randomly select a number between 1 and 3, right? Again, here in this case, in this visual, we're seeing that n is 3. So we're saying randomly select a number between 1 and 3, and that is going to tell you how you're going to start. Let's say you randomly select number 2. That tells you that you're going to start with individual number 2 on your list. So individual number 2 is going to be part of the sample. And then after that individual, you go ahead and select every third individual on your list. So let's look at an example. A store manager wants to measure the satisfaction of the store's customers. The manager decided to obtain a systematic sample by serving every 8th customer. So in this case, our n value is 8. So how is he going to start? Well, he needs to randomly select a number between 1 and 8. And let's assume that he selected 5. The 5th customer exiting the store is going to be the first person who's part of the sample. Okay, so that is going to be the first person that receives the survey. And then after that, every 8th customer is going to be part of the sample. We're going to stop once we collect 50 surveys. So that is an example of how systematic sampling can be used. Notice think about it. Why is the store manager using this method? Well, he doesn't know how many people are going to stop by on a given day or on the day that he's conducting the survey. And also, he wants to make sure that he randomly selects people and that he's able to give them the survey as they're exiting the store. So he's trying to get them on the spot. He's trying to still randomly select them while also being able to give them the survey as they're exiting the store. Now, I am including another method here, which is commonly used. It's not random. You should avoid using this method. This method is what we call convenience sampling. This is going to involve using participants or individuals that are available to you. Okay? So an example of this would be, let's go ahead and consider the college population. And let's say that you post an online survey on Facebook and you ask all the students you can find to complete the survey. Are you likely to find all GRC students? You might just be able to find students that are friends with you or students that use Facebook. This is not going to be a good representation of the population. Okay? Another example of this would be, let's say that you want to give a survey to GRC students. So you decide to stand by the student union. And when you see students pass by, you give them your survey and you ask them to complete the survey. Okay? Again, not a good representation of the population. You're only going to perhaps find students who are taking classes in person. You're now going to be hearing from students who are taking online classes. And so again, the sample that we get using convenience sample is not going to be a good representation of the population. Okay, so avoid using this method. I just wanted to mention it because it is oftentimes used. So in research, you won't see this method being applied. I already gave you some examples. We went through each of the sampling methods. And so now I want to give you some time to read some examples and identify the type of sampling method that is being used. So I want you to try this on your own. One of the learning objectives of this lesson is to be able to identify the type of sampling method that is being used. Okay, so go ahead and consider number 6, part A through E. And I will take some time to give you a warning here. When the sample is not a good representation of the population or does not represent the population, the sample is said to be biased. Okay, so when you're considering a research study, you should ask yourself, what type of sampling method did they use? Is it biased? Is the sample biased? Does the sample represent the population or not? Okay, so I just wanted to give you that warning. Again, go ahead and answer the questions above.